So how does one go about exploring a data set? Let me give you just a glimpse into an actual data set I have. I've had some sleep problems in recent years, and so I got a Fitbit, which is a little wrist tracker. Not only does it track sleep time, but it also looks at different stages of sleep: the dreaming stage, lighter stage, deep stage. So I thought that this could perhaps provide some helpful data. Uh, I collected data on each one of these rows as a single day. So what I have here is called an N of 1 study, or N equals 1. N is the variable we use for sample size, and I'm saying that I'm really just conducting this study on myself. However, it's a little deceptive because the sample size isn't really 1. What we have is each row of the spreadsheet here is a data point. So I actually have lots of data points here. It's trying to make predictions. I'm trying to learn about my own body. So that's the one that we talk about, or that Motulsky talks about in his book. So what variables did I collect? Well, the day, of course, I want to do. This heads, tails things was a little thing I was trying to check whether or not it made a difference if I read before I went to sleep or was doing stuff on my smartphone, whether that actually made a difference in my quality of sleep, when I actually went to bed. Of course, all the data from the Fitbit, but I also looked at things like whether my girls were crying, did I have a nap, did I have white noise on, and some qualitative data that I just made note of in case I would have any extreme values and I wanted to remember a little more about that particular day. So let's take a look at a couple of the individual data, and this is what exploring data starts with. It starts with looking at an individual data. Let's start off with this variable here in column P. This is the total amount of time each night that I was in bed, from when I laid down in bed to go to sleep to when I actually got out of bed the next morning. So it includes much more time than I was actually asleep each night, laying there trying to go to bed, things like that. And as Motulsky suggests, I think one of the best things to do is visualize the data. If you select, notice if I click one of these letters above a column, it selects the entire column. So I'm going to click that P, and that selects this entire column. Then I'm going down to the bottom right with this star. If I hover over it and click on it, left click on it, it gives me this really nice way to conveniently explore the data. It starts off with some summary statistics. In this case, adding all the numbers up isn't very helpful, but an average could potentially be helpful, 416. So this would be just shy of 7 hours per night that I'm in bed, according to this. A minimum of 2. That means I have a data point in here that said I was only in bed for 2 minutes that entire night. That's suspicious, and the min and the max are two of the first places we might start to find suspicious data. The max here is also pretty suspicious. If we divide that by 60, let's see, what would we get? Something that's definitely higher than the amount of hours that I would sleep. 20 hours would be 1,200. So this is like 19 hours in my bed, which is definitely not realistic for me. Count is the number of data points, so 27 data points here. So I've got some suspicious stuff going on, and I could go into the data to check that out. When you have a much bigger data set, it's harder to go into the data and find it. Here's where a visualization can be really nice. So I'm looking at this histogram, which is good because this particular variable, I could ask myself, is it interval? Is it ratio? it's certainly at least an interval level. The question is it interval or ratio? And the difference between the two is a little bit subtle. The book talks about, does it have a meaningful zero, or does zero actually mean none of whatever it is we're measuring? And in this case, it does. 0 minutes in this column would be 0 minutes of time spent in the bed. That would be a meaningful number, unlike 0 degrees Celsius, which isn't really zero of anything, because then you have negative degrees Celsius, and the book goes into that in more detail. So I do have a ratio variable here. A histogram would be a great way to look at that. Let me just drag it out here. Maybe got my little head cut off here. There we go. So I can see pretty clearly I have what's called an outlier, and if I wanted to, I could go into the histogram, change the bucket size. Maybe that's a little too extreme. Maybe to 25. And here I can see actually I have 2 extreme outliers. So I would be able to see these outliers even if I had a data set with thousands of data points. And by visualizing this data, I would see that something's going on. Notice that just looking at the average, I might not have caught this, because the average of about 7 hours in bed, that does seem reasonable. But when I visualize the data, I can clearly see I have some unreasonable points in here. So I'm going to just delete this, or actually just slide it over to the side. And I can see here that 2, and I can also see that 1,139 that are not correct. So I could delete those. It'd be nice to go in and figure out what's happening there. If I look at that row, I know that this is taking my sleep end, and it's subtracting out the time I started trying to sleep. And here I see what the problem is, actually. Because this is a 24-hour clock I was using, 12:06 would be just a little after noon, when the reality was this should be 12:06 right after midnight. And notice as soon as I correct that, that adjusts my total time here, which is the actual number that I should be using here. So this was a case where instead of deleting it, I was able to preserve the data point because I figured out what the mistake was. It was a data entry mistake. Do we have a similar thing here? Here we have going to bed right before midnight. The issue here is we don't have a sleep end. So in this case, I can't really use that data point, so it would be better to get rid of it, at least in terms of the total time sleeping. And now if I relook at that, I can see an average that's much more meaningful. So it's looking like a little over 6.5 hours per night that I'm actually in bed, not necessarily sleeping. And that histogram itself looks a lot more realistic. Next thing I might take a look at is total sleep, so the time I'm actually sleeping. This is also a ratio variable. 0 here would mean 0 minutes of actual sleep, which is meaningful. Incidentally, since I have 2 ratio variables here, and because this is really a part of the total time I was in bed, I'm not doing any sleeping outside of the bed. This is all coming as part of this total time. I could even create another variable that might say percent of time in bed that I'm sleeping. I probably could have come up with a better name for that, but this would be an easy thing to calculate. Because these are both ratio variables, I could just take the total amount of sleep divided by this one right here. And notice that I want to take this formula and drag it down, at least where I have all the data here. And then I have lots of ones. One would convert to 100%. And I'm certainly not sleeping 100% of the time that I'm in bed. So if I go to format here, number, I can change this to percent and see, I think what it was doing is rounding up to the nearest 100%, which rounded all of these up to 1. So here I can see a nice number percent of the time that I'm sleeping. I might even take a peek at that. Here I'm seeing some outliers again, which is this right here. This I didn't have a total amount of time sleeping, so I would have to perhaps delete that, and this would give me a more accurate view of the percent of time I'm sleeping. So I can see that typically tend to sleep about 85 to 95% of the time that I'm in bed. These other two variables are a little different in that they're either 0 or 1, because either I was reading before bed or I wasn't. Either I was watching something on the screen before bed or I wasn't. These are what we call binomial variables. Sometimes they're also called dichotomous variables, and they show up quite a bit in health and medical research. The author talks about die, not die, heart attack, no heart attack. Things that either happen or they don't get coded as a binomial variable. So these are a little different. If you look at them, you can still see some meaningful stuff. The average here is meaningful in the sense that it tells us that 45% of the time I was reading before bed, but beyond that it doesn't tell us much. The min and max, it's good to see 0 and 1 there. Otherwise, I'd probably have some missing data I needed to address. The histogram doesn't really make sense here. So I'm not sure that the visual would do much for me on these two variables, but they're still very useful in analyzing. What we'll do later in the course is I might separate these nights into the nights when I read and the nights when I use screen time, and then calculate whether or not there's a significant difference in the amount of time that I'm sleeping on the nights when I read before bed and the nights that I had screen time. So we're getting to that very soon here in a couple weeks. But that's the general gist of data exploration, looking for outliers, correcting data errors, looking for general patterns, looking for what the shape of the distributions are.